look at that. I see new souls. Yes. But tonight I've got 3 horrific tales filled with numbers and symbols that you dare not solve.
A cryptic tale of 2 integers.
Let a and b be 2 positive integers, so that a squared plus 2ab minus 3b squared minus 41 equals 0. Find the value of a squared plus b squared, if you dare. Pause the video now if you'd like to give it a try. From algebra, we learned that a plus b quantity squared is equal to a squared plus 2ab plus b squared. Our positive integers a and b must satisfy the equation given here. Do you see the connection? We can rewrite our equation as follows. A plus b quantity squared minus 4b squared equals 41. The left-hand side of this equation may look familiar to you. You see, this is the difference of 2 perfect squares. The formula for which is x squared minus y squared factors into x plus y and x minus y. Therefore, the left-hand side of our equation factors into a plus 3b and a minus b. Now notice that the right-hand side of our equation is a prime number, 41, which only factors in one way, 41 multiplied by 1. And since a minus b is less than a plus 3b, since a and b are positive integers, we can conclude that a plus 3b is 41 and a minus b is 1, a system of equations that is easy to solve. Subtracting the second from the first, we get that 4b is equal to 40, and that gives us b equals 10, and a equals 11. So now we are prepared to give our final answer for the problem. A squared plus b squared, or 11 squared plus 10 squared, is 221. Did you figure it out?
Treat or complex trick.
Let x be a complex number, that is a number of the form a plus bi, where I is the square root of -1. And this complex number satisfies the equation x squared plus x plus 1 equals 0. Find the value of the sum of the powers of this complex number given here. Pause the video now if you'd like to figure it out. So our goal is to evaluate this sum of the powers of our complex number. Now, since x satisfies this equation, this quadratic equation, it also implies that x squared plus x equals -1. And x squared plus x plus 1 can also be written as x cubed minus 1 over x minus 1, which is also equal to 0, and that implies that x cubed is equal to 1. So, cleverly factoring out terms in our expression, we can get 1 plus x squared and x plus x squared to pop out of it. And thus, our sum is equivalent to x to the 51 power times negative 1. And x to the 51 power is equal to 1 to the 17th power, which is 1. Therefore, our sum is equal to negative 1. Hey there, boils and gargoyles. Hit that like, subscribe, and notification bell for more videos.
A little exponential madness.
Let n be a positive integer. Find the smallest value of n such that 2 to the 8th plus 2 to the 11th plus 2 to the nth is a perfect square. Pause the video now if you'd like to figure it out. Two to the 8th plus 2 to the 11th plus 2 to the n is equal to m squared, our perfect square. Rearranging this formula, we get 2 to the n is equal to m squared minus 2 to the 8th minus 2 to the 11th. And we can rearrange some of the terms in there, and this now reads 2 to the nth is equal to m squared minus 2 to the 8th times 9. And this is the difference of two perfect squares, so we can factor it as so. And therefore 2 to the nth is equal to m plus 48 times m minus 48. So now we are going to use a little deductive reasoning. Now, since n is a positive integer, we're going to let 2 to the n be equal to 2 to the k times 2 to the n minus k. And that's equal to m plus 48 times m minus 48. Again, we set up a system of equations. And solving this system of equations, or by subtracting one equation from the other, we get 2 to the k minus 2 to the n minus k equals to 96, which factors into 2 to the 5th times 3. Then, doing a clever factoring on the left-hand side, we get 2 to the n minus k, multiplied by 2 raised to the 2k minus n minus 1. And therefore, we can equate these two pieces together. From the first equation, we can get that n minus k is equal to 5, and that makes n equal to k plus 5. Then from the second equation, we can get that 2k minus n is equal to 2, and then 2k minus 2 is equal to n. So equating these two things together, we get k equals 7, and therefore n is equal to 7 plus 5, which is equal to 12. It is the smallest positive integer n such that our sum was a perfect square.
All right, you've all survived. But stay around if you dare.